Today, I wanted to focus on hard drives and how to pick them, how to go through numbers and figure out like what are the actual stats that we should be looking at that will better inform us as to like what drives will best fit our application. And that's very important to figure out, like what is your application, how are you going to use this storage. And ultimately, all those answers will start to paint a better picture as to like what route to take.
What type of applications are you looking at here?
I definitely want to frame this entire conversation around bulk storage, and that means we can essentially go into two different routes: SATA or SAS drives. For SAS, for the sake of this conversation, we're only going to focus on what is known as nearline SAS drives, which means which are the 7200 RPM drives, because there also exists the 10K and 15K RPM variants, but those are a different application. They're not meant for bulk storage because those drives are less dense. They also utilize more power, and they're not competing for the same space as what bulk storage hard drives are. Like they kind of compete against SAS SSDs, but that's questionable nowadays.
Yeah, and so I remember running like the 10K RPM drives in my workstation for a while. I don't have them in there anymore, but I remember using them for like that same use case of like I wanted better performance out of my workstation, the thing that I'm either using personally at home or basically now from working from home forever. Before all the other stuff that's happened, in the world here, having worked remotely for like 7 years at this point, being able to use it for a work machine also, I'd be able to get better performance that way from what I do on a day-to-day basis. So like what does bulk storage mean in that context? Does it mean like loading a bunch of drives in my workstation? Does it mean having a some kind of home setup, home office, small office setup, or I've offloaded that storage somewhere else? Does it mean I'm running my own data center? What are kind of the boundaries of that?
It could mean a few things, and it like I said earlier, it very much depends on your application. So if you're just wanting to archive a bunch of Blu-rays, for example, to stream on your local network through Plex or something like that, then we're looking at a small QNAP or what's the alternative to QNAP nowadays? Synology NAS, where we just plop in 8 or so drives. That's one small application to get started on, or we can go full-fledged higher dense bulk storage, such as a JBOD, kind of like what you have, or kind of like what I'm running, where we can have up to 45 or 60-ish drives in just one appliance.
Gotcha. So basically like a machine that has a dedicated set of drives that I'm using either in my home office, possibly small office setup. That's kind of like that centralized storage for that location that other machines, multiple machines can go connect to that and use that essentially as kind of like one big drive.
Yeah. And very much depends on like how it is that you want to set up. Like it's perfectly fine if you set it up in like they do exist PC towers that have like up to 12 hard drive bays, so you can just plop them in there and connect all 12 to your motherboard via SATA. That's a perfectly fine solution to get started. It can also be economical because those cases are like $100. So it very much depends on like how much you're willing to spend on this project, and what you're going to be using it for. If you're going to be using it for more than media streaming, music streaming, and whatnot, and you want to use it for like daily backups, or just consolidating data because you have a bunch of external drives that you don't want to label or keep track of, it's it's a good way to start consolidating all your digital life essentially.
Gotcha. Okay. Yeah. And I assume there's probably some other cases like that. If you're doing video or other media like we do, there's a lot of data there. And so that can be a good place to store that rather than having to keep a bunch of, say, like external drives that you've got to organize and make sure that are backed up and have, copies and all that kind of stuff. As well as like data sharing between computers. So if either you're using multiple machines or you have multiple people that need access to the same files, CAD could be a good example of that. So if you've got several people working on like the same CAD project or any of those kind of like engineering pieces of software, kind of work like that, where you might need shared assets between computers and people that are working on those. Mm-hmm. Trying to think of some of those other use cases, but some of that stuff can kind of fall in there, it sounds like.
Yeah, a good use case is also like just sharing with the people that live at your house. Like they might want to listen to the same music or see videos or see documents that you want to share with others. It just makes it extremely easy for others to access data that's on your network. Mm-hmm. And so now the main topic of today is how to pick drives. Like what information should we be looking at in order to determine like what drive is probably going to work best for my use case, and what should I be looking at? What numbers should I be looking at so that I get informed to stay away from those drives, essentially. Like, what are the good ones? What are the bad ones? And how can I determine that? Mm-hmm. And before I get into that, there's some context that we first need to know. So a few years back, maybe going back 7 years, it was widely known in the industry that SATA drives would fail in very unreliable ways. That could be from mechanical to firmware or related to just issues with the NAND flash or the cache flash that was on the motherboard on the hard drive. Like there's a lot of factors that would essentially cause the SATA drives to fail. And then there's other things within SATA itself that made SATA drives incredibly unreliable. However,
is that something that was like consistent across like number one product lines, but number two, like drive technologies as well? So drive technologies being like spinning Rust versus SSDs, like did those have a difference there? And then product lines being like, just using like WD for an example, because I know their stuff off the top of my head, like did WD Blues, which are their consumer line, if I remember right, like the typical thing you'd get, the typical drive you get in a system off the shelf for like Best Buy or something, did those see any differences between like Western Digital Black, which were their more performance-based drives, versus Western Digital Red, like Red Pros especially, which were their supposedly most reliable drives? Like were there different stats in there, or is this kind of like a general trend that was seen across all SATA drives?
It was a general trend, but it definitely differed between brand and SKUs also. Mm-hmm. And that's why it's Backblaze and their stats that they release every quarter for, I don't even know however many years they've been doing this for. But there's one interesting thing that's been occurring recently. So we do know that in the past, failure rates were kind of sporadic for SATA and just unpredictable. Like you couldn't really predict, and the software such as Smart couldn't really consistently predict failure for a drive. It's just like, oh, it's starting to fail. Let's just mark this one as bad now.
And briefly, what does Smart do?
Smart runs, I don't really know like the specifics, but it runs a series of tests, which helps it determine if a drive is either healthy or not healthy. There's no in between. It's either okay or bad.
And if I remember right, those are stats essentially that are stored on the drive itself, right? That tells you when you plug that drive into a system, essentially whether the drive is good or bad. Although it comes with like quantitative numbers where you actually see, like, here's a number of failed writes to the drive or something like that.
Okay. Yeah, there's definitely a few metrics that it tracks. It tracks how much data has been read and written to that particular drive. It tracks lifespan, so how many hours has the device been on, and it uses those numbers to actually factor its decision for its current health. And like I said, I don't know how it's calculating that, but yeah. But there's one interesting thing that has just hit me like a few days ago. The consistency in failure for SATA drives has sort of normalized these past few years, and it seems to be more consistent.
Okay.
As we see in this chart here. The spike what attributed to the spike could be like one SKU or one particular brand. There's another chart where we'll see like essentially this sort of trend, but on a per brand basis, which gives us a lot of information. Like this, it'll tell us like exactly which brand we want to buy from. But we'll get to that in a bit. And it's interesting also because it's also the most expensive hard drive.
There's something else that looks a little suspicious to me when I'm seeing that chart. And granted, this is also the first time that I've seen this chart. Mm-hmm. And that dip happens basically after Q4 of 2019. And we'll just say there was some stuff going on in the world at that time, around that time that started. And so like technical, in the tech industry, at least, that means there were supply chain issues that started happening around now. And there was also this massive movement of people essentially not having company supplied computer or like computers that they had like at work. And there was that bigger push to work from home and be able to get people equipment at their homes and stuff like that. And it makes me wonder if any of that is part of this trend or if that's just an anomaly here, like to that. Because I guess another one of the things maybe around this too is did SATA drives kind of go out of fashion by this point? And was NVMe more of a focus around the time that we're seeing these graphs? So like maybe everything I'm thinking around that is maybe not a factor. And
that's an interesting point that you bring up, though. I don't think the NVMe and SSD stuff can actually plug in here because Backblaze just uses SATA drives. That's all that they use.
Oh, so this was just what Backblaze noticed from their services. From
their own drives and drive failures.
Okay, so this wasn't like a user survey or anything like that. These are internal metrics to Backblaze. Yeah. Gotcha.
Yep.
Okay, that's really interesting then. So yeah, what I was saying probably doesn't apply here.
Yeah, not quite, but it's something that we might touch on a little bit later. So like we see here, this line is a little bit steady, and it's very interesting as to why this is occurring. I do know that Backblaze does retire chunks of drives ever so often. But it's starting to look like the more recent generation of hard drives are starting to fail in a more consistent fashion. Mm-hmm. And I like that. I like that a lot because it just means that maybe SATA is becoming as reliable as SAS drives. Because the big recommendation 7 years ago was, we can't really predict the failure. The SATA drives just predict in a very unpredictable way, but SAS doesn't really. I couldn't really get a whole lot of metrics because they're all behind data centers on SAS, but that was the general consensus in that space. It's a shame that like Backblaze doesn't use SAS drives because they would have these numbers also. And there's a reason why they don't use them, because they provide a very cheap service. And they also want to get their drives as cheaply as possible. And SAS is slightly more expensive than SATA. So now,
do we know what drives they typically use? Like, do they prefer a certain series or anything like that? Or is that kind of behind closed doors?
We know like the drives that they use. Well, they typically buy like, let's say like 10,000 drives of one specific SKU, and then they install those. And that's like their bucket for that SKU, for that brand, and they don't add or remove unless they die. Obviously, they replace them. Or do they? I don't think they replace them. They just let them. No, that wouldn't make sense. They would replace the failed drives, right? Mm-hmm. But I don't think they increase the pools for that SKU, because then that would invalidate some of the data at the end, because we're trying to see how many of this static pool fails over time. At least that's my understanding from the articles and charts.
Gotcha.
There's some interesting stuff. We'll get into that. So before we get into like what is the determining factor, now that we know that SATA is beginning to be more reliable, let's talk a little bit about like what is SATA and what is SAS? Like, what are the differences? And should that factor in to my decision making? And as I said earlier, I definitely want to frame this around bulk storage. So when it comes to SAS, we're going to be looking at what is normally referred to as the nearline SAS drives that come in at 7200 RPM. And that could be like the Seagate Exos series that are helium filled. There's the Iron Wolves, I believe, are NAS. Oh, but they're SATA. They're not SAS. Western Digital has SAS drives also. Is that correct? Yes, they do.
Are the Golds the SAS version? I think they labeled the Golds as Enterprise, but I can't quite remember.
Probably most Enterprise branded hard drives through Seagate, Western Digital, Hitachi are usually in both variants, SATA and SAS. So that could be it. I don't know. I didn't actually look at the SKUs. But I know for sure Seagate has Exos, because that's mainly what I've been using. And I don't know, what is the one for Hitachi? Is it the DC data center SKU?
Oh, I don't know off the top
DC
of my
550.
Head. I'd have to look that up.
That might be one.
Okay.
But anyways, first regarding SAS, we'll be looking at nearline SAS and not be considering the 10K or 15K RPM SAS, which is what most people consider as true SAS. I didn't know that was really, I didn't know there was a distinction there. But anyways, what is SATA? So SATA typically is more accessible. So it's cheaper devices. They target the consumer market. Originally the successor for parallel ATA, if y'all remember that. SATA is half duplex. And there's some gotchas to that, but I'm not gonna get into the gotchas yet. SAS is typically more expensive.
And so first of all, so SATA is basically what we've been used to putting in our like home machines for the last at least basically since ATA went away, parallel ATA. But yeah,
it's what we see like when we go to Best Buy and buy just a pre-built PC, like there's going to be a SATA drive in there 100%. And it makes sense because like consumer boards, even like consumer boards are mainly gaming boards, essentially. Like all consumer boards are gaming boards to a certain degree, except like the more niche creator boards by like ASRock, for example. And you will never see a SAS controller in a regular motherboard. That's never happened. And without a SAS controller, we can't really use SAS drives.
So what else? What else are we getting by going to SAS drives? Well, why is there
So,
even a difference in the first place?
one, SaaS is definitely more expensive. They target critical server applications. SAS is full duplex, so we have bidirectional communication there. There's one very cool thing. They use higher signaling voltage, which means the backplanes for SAS are going to be simpler because they just don't have an additional power receptacle to supply more power for the drives. A SATA backplane is going to be a little bit more complex in that regard, and probably only going to be able to support a few SATA drives for thermal considerations, for example.
Does the higher voltage help at all in terms of like signaling in noisy environments? So if you've got, say, a lot more SAS drives in the same chassis, basically stuff that's going to make more electrical noise along that bus, is it designed to help there at all, or did they do it for some other reason?
I'm not sure. That could be one thing, but it definitely simplified the power delivery.
Okay.
Yeah. Because like in the SATA variants, you'll definitely see like a 4-pin Molex power receptacle in those backplanes. I know what's that company, Icebox or Ice something. They make a 5-bay backplane for SATA, and there's definitely a 4-pin Molex. You're not going to be able to get away on not adding one because it needs additional power. And also the higher signaling voltage helps with cable length. Like SATA cables are, the typical max length is 1 meter versus SAS can be up to 10, I think, if I'm not mistaken.
And so like what we've talked about before, that actually allows you to run external cabling to your hard drives, like to an external JBOD, to some other drive enclosure that you can have basically outside the chassis. You don't just have to do a motherboard to drive run like you might do in a consumer system.
Right. And then we get into errors and how each drive handles those. I know.
Before you touch on that, you glossed over half versus full duplex a little bit, and what are the differences there, and why should somebody even care about that?
Yeah, so in a half duplex scenario, we can use the analogy of like walkie-talkies, where I'm talking to you over a walkie-talkie, and before you start to communicate back, I have to say over to let you know that I'm done talking, so that you can start, your response. And it's all happening via just one pipe. Like we send data, and we can't receive data on that same pipe at the same time. It's one or the other at any given point in time.
Right. So half duplex is only sending or only receiving. Exactly. The traffic can't go both ways at the same time.
And full duplex is, allows for bidirectional communication. So we can send and receive data at the same time. This also could possibly help with IOPS, although from the data sheets, it suggests that it doesn't. Like we'll get the same IOPS on both SATA and SAS, but in practice, that might not be the case. So that could be a very good factor as to why not go SATA and why SAS is a very good option.
Is there interoperability between them? So like, can you use one of the drives with another controller or vice versa? Or if you get one type of system, are you just locked into that type?
That's a very good question. So if you have a motherboard, for example, earlier we touched on consumer grade motherboards that we would just buy Best Buy or whatever. And you'll just have a motherboard that's compatible with SATA drives. With SATA, you can't plug in a SAS drive. With a motherboard that has compatibility for SAS, for example, you can plug in both SAS or SATA. Like it's compatible, backwards compatible for SATA, but it doesn't work the other way around.
Gotcha. Cool. So it sounds like at least if you ever plan to go SAS drives, or you plan to do like remote your drives out or something like that, then you probably want to be thinking the SAS controller route, but you could go with either type of drive depending on your budget and your other requirements like you just described. Otherwise, if you've already gone SATA, so for example, like if you're trying to retrofit maybe a really performant gaming machine or other really performant system that you've had laying around, and you wanted to turn that into like a home lab server, if it only supports SATA right now, if it's only got SATA drive connections, you're not going to be able to retrofit that with SAS drives unless you went out and got a SAS controller and possibly a backplane to go with it and some of the other kind of SAS infrastructure. So if you start with SAS, it will let you use SATA and basically upgrade your drives to SAS drives when you want to. If you start with SAS, you're locked into SAS from the kind of infrastructure, controller, motherboard, all that kind of side of things.
If you start with SATA, you're locked in with SATA.
Mm-hmm.
Yeah. Yes, that's 100% true. And that's why it's a very good reason as to, like, for example, the JBOD that you went, it was extremely I think it was extremely inexpensive.
I got a good deal on it.
and it has a SAS backplane, right?
Yep.
So you're able to switch over from SATA to SAS if you wanted to, and you have that flexibility.
Yeah, and your data here is probably going to sucker me into it. I have the feeling at the end of this, going to end up ditching all my SATA drives after this, I bet.
I don't know. Like, this first chart that we were looking at is very compelling.
I'll just leapfrog it and go in VME.
There you go. So one big difference between SAS and SATA that we haven't really covered here is the error reporting. Earlier, we slightly touched on, Smart and what that was, but it is widely known that SAS's error recovery and error reporting uses SCSI commands, which has way more functionality than your standard ATA Smart. I haven't fully dived into it personally to understand the limitations and how much more metrics I can pull out of it, but that is the general understanding around both, which means from what I gathered from others, you'll get finer grain metrics around just failure rates. You'll have better data, and the way it fails might be better than how a SATA drive would fail, because of just how maybe the firmware was written, or the just overall error recovery aspect of SAS works, and that just doesn't exist in SATA.
So when you say how it fails might be better, do you mean like there's a better chance that when it fails, there's some way you're going to be able to pull your data off that drive? Or does it mean like it might take longer from the time it reports the drive is bad to the time that it actually like stops working in your system altogether? Or like, how does that actually like manifest itself in practice?
I'm glad you're asking that really good question.
Am I unrepressing some terrible memories of yours here?
Sort of. So in SATA, and this actually touches on the graph. In SATA, years back, there was something known as the silent data corruption. There was many factors in SATA drives that would contribute to data corruption and failures. And those factors could range from bad bit flips in the cache flash, mechanical, and or what are the other ones? Firmware. Oh, firmware is a good one. And it was very common to just have very unreliable SATA drives. And that's That's why CFS is engineered the way it's engineered. It doesn't trust any device that you hook up to it, because of this. This could be one main contributing factor to that engineering decision. But we're not seeing that anymore, as we just previously saw from the chart. We're not seeing that that drives are failing in sporadic ways. But there are anomalies. So I think in 2019, was it Q3 of 2021, there were two outliers in, I believe, two pools of drives that Backblaze put into production, and one of them was both of them were Seagate. One was a firmware issue. One of the pool they bought from Dell and were operated on Dell hardware, and once they updated the firmware on those drives, the failure rates greatly diminished and went from like 5.6% down to like 4.6% for that quarter, or for the entire year. I don't remember the difference there. But we're starting to see like these silent killers creep up. And in this case, firmware was one of those cases. Like, it wasn't really a mechanical failure that they could definitively say. But once they updated to latest firmware, things got better. So that tells me that, oh, maybe there's something in the firmware that was just not doing the right thing. And I've read of cases where, like, I don't know, the drive is starting to fail, but in the firmware hasn't responded fully back to the Linux the operating system. So the operating system still thinks that we're reading, so we're waiting for end of file essentially, but the drive never sends that. So you can't really remove it from the RAID array because the device is busy. It's in a busy state. So that means you can't fully remove it from the RAID array. And now you're kind of left in a weird situation where you can't remove the device and the array via software, so that you can replace it with a good one and start with the resilvering process. There's like weird things that could just creep up that is just solely related to firmware.
So like when you're doing that replacement process, for example, and maybe some folks can relate to this when using a USB drive in their computer, like a USB flash drive, you can't just go straight in and, well, I guess you kind of can, but you shouldn't just go straight in and rip a disk out of a computer, right? So you want to make sure that it's shut down safely. And I guess granted here, we're typically talking about servers or like a NAS, which is essentially like a server that's got a bunch of hard drives connected up to it and it serves storage. Those are appliances that are designed to be running basically 100% uptime. Like, they're designed to be powered on the whole time. And those are things that they're units that are designed to be able to switch out certain pieces of hardware, hard drives being one of them, while they're still running. So because like if that's serving up your whole small office, for example, or your data center, actually, if you scale it out to a really big case, you don't want to have to turn off the entire system and stop what it's doing just if one of your drives fails. So you've actually got a process you can do by going in there and saying, hey, I want to be able to remove this one particular drive from the system. It'll safely power it off. Like you said, it'll flush its queues essentially, which means make sure that everything that needs to be written to disk that was queued up gets written. Anything that needed to be read off of it got read off of it. And then it kind of like stops those pipes and says, okay, no more reading and writing here. Safely powers off the drive, and then it lets you pull it in a safe way while that server is still powered on and running. And so what you just described was the firmware in that drive was then locking up was essentially not communicating back to the computer's hardware in the correct way. So the computer had it, like the drive would never be able to say, hey, I'm ready to be ejected. Like you can pull me out of the system now. It would just kind of hang there and do nothing. And now the system can't tell you as a user or a system administrator, like, hey, your drive is safe to physically pull out now. It's just confused and says, well, I went to shut down the drive and nothing happened. So your system is kind of hung there.
Yeah. And in a RAID array setup, you should be able just to like yank the drive out. Mm-hmm. The problem and the risk goes up when you have the entire pool is using the same variants with the same firmware, and maybe that causes like downstream detrimental effects to the other drives, and now your entire pool of data is at risk essentially. And there used to exist a lot of those issues. We're starting to see that those sort of anomalies don't really occur in practice a whole lot. Backblaze side in 2021 Q3 with those two SKUs with custom firmware from that OEM. But for example, I haven't really experienced that myself, although I'm not running thousands of drives at all. But that's one good reason as to why we should look at these numbers, because Backblaze is running a bunch of these devices, and it's a good lens into which variant of which device, of which manufacturer is going to be reliable for my use case. At the end of the day, we have to be a bit accepting of some risk, but that's your personal decision there. Like, you're going to have to ask yourself the hard question of like, how much risk am I willing to take on for my RAID array? And that's only a question that you can answer.
Which is also why we have RAID in the first place. So we're not just running on one disk, and if you lose that disk, you lose all your data. We've got RAID so that we have essentially drives that have parity across them, but essentially like this array of disks where you can lose one or more depending on how you've got your array set up. You could lose one or more disks and your array still runs and gives you time to replace those drives that failed.
Yeah. So now that we talked about this, how do we actually choose a drive? There's a lot of information online. What does it all mean, and how does it apply to me or to you? We touched on that a little bit, and it's very dependent on your application, your use case, and the amount of risk that you want to take on. Now let's look at what numbers I should be looking at to help me decide on drives. And then we're going to look at what not to do, what drives to definitely not buy, and why. So I skipped over this tab. This chart is beautiful. It basically tells me between 2019 and 2021, the consistency of failure rates across brands. So this chart is just amazing. It gives me the right amount of information per manufacturer of hard drives that can help me determine which brand I might want to go with. We can then later dig deeper into the quarters of each year to see like which SKU from that brand performed best. And there's definitely some very interesting information. Like there's one, I think it was a 6 or 8 terabyte SKU that has been in operation for like 7 years.
That actually sounds like a good home lab SKU, because you don't want to really be replacing your drives and stuff like that. You're probably more sensitive to the cost of replacing disks that fail than maybe your typical, data center or Backblaze, for example, might be.
Yeah. So when did I start? 2012, 2013. That's when I started my home lab experience. I had a rule And that rule is now, based on all this information, is changing. I had a rule of I'm not going to keep a hard drive past 3 to 5 years. Like that was going to be the max lifespan in operation for any given drive that I install in a RAID array. Mainly because I was extremely paranoid for failures, because I did have failures. And I had failures across Seagate and saw that I had less failure with Seagate than with Western Digital drives. It could have just been the times. Like they just didn't align for for that particular brand those years. As we see, for example, Seagate in Q4 2019, we had that huge spike here. Based on the rate of failure diminishing for drives across brands, it might be safe to go to update that rule and just keep it at 5 instead of 3 to 5. There's another good thing as to why and the reason for keeping it that way. And it's also very close to the amount of years in warranty that most of these devices have. It used to be that, like, for example, consumer level Seagate hard drives, they typically had a 3-year warranty.
So when you say consumer, do you include like their NAS drives, so like Iron Wolf, for example, in that? Or do you mean like the lower ones that you'd find in, like off the shelf at a Best Buy?
I might be wrong, but I believe that even those a few years back might have had a 3-year warranty, but now they have a 5. Mm-hmm. And so if I have a RAID array, for example, RAID 6 or in CFS, RAID C3, for example, where I have 3 hard drive parities, and one of them fails at year 4, well, I could just send it back and get a replacement. And I still have 1 year left in my warranty period for that new drive. It aligns very well with that warranty period. But yeah, I'm thinking of just updating my rule across my home lab for this specific reason that we're seeing here.
Gotcha. So yeah, one of the things I was thinking of was the replacement cost on a 3 to 5 year schedule, which if it's still under warranty, that's really nice. If they were failing, so like, let's say the warranty wasn't a factor, like it doesn't exist, would that still change like your 5-year timeline, or would you think about it a different way in that case?
I don't think that would change my 5-year timeline unless a drive definitely fails before then.
And so would you change them out in batches if you did that way, or would you like stagger the replacement? Or I guess either what do you do now for that, or how would you handle it if basically you're paying for them out of pocket?
It depends on the pool size. If it's like fairly large pool, then I would probably do batches of 6 or 8. If it was a small RAID array of like 6, 8 drives, maybe 2 at a time, or even 1 at a time, and then just keep a few spares.
And over
just
like
in case.
Over like what interval in that time frame? Are we talking like once every couple weeks or once a month, or?
Not sure. That's a very good question.
Once every paycheck comes in because they're going to be expensive.
Once every paycheck, probably. That's a very good answer. I would have to say relatively close to the previous swap, because each swap, each resilver is adding additional strain. And if the other 5 drives are extremely old, you don't want to wait a few months in between, because that's just increasing the chances of the next drive to fail. And if you replace the next drive, the chances just keep increasing for the other remaining drives to continue to fail.
You mentioned keeping spare drives around. Does this change your strategy, or like what shapes your strategy around how many drives, how many spares you keep? And like, if you're planning out replacing them before their failure period, especially like well before their failure period, it sounds like why still keep drives around, or like, do you, you need to keep significantly less of them than you would otherwise? Like, what's your kind of strategy behind that?
I would only keep like 2 to 3 drives spare per variant that I have. Like I'm running CFS and I have a few VDEVs that are 16 terabytes and I think only one that is 14 terabytes. So I obviously need to keep 2 different SKUs of drives, and I would probably keep like 2 to 3 of each. But I definitely wouldn't go out and buy like a whole VDEV replacement. So it's just way too much.
Does that break down? Does that break down into some kind of ratio? Because if I were running a pool of like 8 drives and you're telling me to keep 3 spare drives around, then that's close to 50% of my pool. That's a pretty high number. Whereas I know in reality, like you're running a lot more drives than that. I think 32, if I remember correctly. So does like your ratio scale there for folks who might be running a smaller number of drives?
So currently I have 3 VDEVs of 16 terabytes and 1 of 14, as I previously mentioned. And I have 2 spares for each VDEV, essentially. It's just your risk factor and also how much you're willing to spend.
And also each of your VDEVs, if I remember right, are RAID Z2. So you can actually lose 2 drives in each VDEV.
Which is why I have still be the 2 spares.
So you won't actually lose an entire pool until you've lost a 3rd drive in that VDEV.
And I don't necessarily need to have, like I said, I have 3 VDEVs of 16 terabytes. I don't necessarily need to have 6 16 terabyte drives laying around. I could just have 2 in the case of the 2 failure drives on one significant pool. There's tricks that you can use in the case of when you do run out of spares, but something else, dies in another VDEV. But I definitely do not want to advise to use those tricks. They're not recommended.
Gotcha.
Have spares.
Yeah. So what other types of stats do we need to know about?
So first, let's dive into like what is this showing us? There's one big outlier here. Like Seagate failure rate is coming down a little bit, and it's looking like it's starting to normalize between 1 and 1.5% throughout the year. But it's still the highest one out of all of them, and all my drives are Seagate, so that definitely it definitely means that I have a big tolerance here. But let's look at HGST, Hitachi, and how low.
And you've actually had a couple. I mean, granted, you have a pretty big pool for a lot of people running a home lab, probably, but you've actually had a couple Seagate drive failures in that, right?
Yeah, and I have my spreadsheet open of like my current drive stats. I think I only have 1 failure so far.
Okay. I remember you sending some other drives back, I think, but maybe those didn't fail. Maybe those were because something else had gone on with those. So, yeah, I think that goes back to when I was first starting to set up my my CFS pool. But that was another issue. The SAS controller, either the primary or the secondary SAS controller for one of the zones on the JBOD appliance was bad, and it was reporting that some of the drives were bad. So I replaced those thinking that they were truly bad, but they weren't. It was the SAS controller on the JBOD unit that was bad. I ended up debugging that issue, taking I think like 2 days to fully debug it and figure out that it was the SAS controller. Figured out which one was it and sent it for replacement. So I did send 2 by mistake, but they were good drives. They weren't bad. Gotcha.
And then there's another thing there. When you send out these drives to get replaced, the manufacturer will either send you, well, you're not guaranteed to get a new drive. That's for sure. If they don't have refurbs, they'll send you a new drive. Yes. But if they have refurbs in their, in their pool of of drives, of available drives, they'll send you a refurb. And a refurbished drive, to my knowledge, is not new, but they claim that it is as if it was new.
So
I don't know what that exactly means.
So
yes.
are they essentially guaranteeing that you're going to get the same lifespan out of it? Or I guess warranty wise, get the same lifespan out of it, not necessarily what it comes out to in real life.
That's what their like new thing implies. I still don't like it, but yeah, I definitely wanted to bring that up because I've also gotten either fully new drives with from Seagate and also refurbs, and refurbs have a different sticker.
Gotcha.
That's how you know it's a refurb.
Okay, so you can clearly identify them.
Yes, you can. One of the trend lines here that I'm really liking is from Hitachi. Like, they've been consistent for the past since Q1 of 2019, but they're also the most expensive hard drive manufacturer out there by a magnitude of like $100, I think. And Seagate is the cheapest out of all three from what I've seen so far. But there's the higher risk factor when you're going Seagate. I'm wanting to switch over to Western Digital, but I haven't pulled that plug yet because I haven't found a good enough deal to convince me to buy a whole VDEV of Western Digital drives. But I think that's going to be my next batch or my next project.
Gotcha. And yeah, like, other than the Seagates that you've sent me in the past, all of my systems have pretty much run Western Digitals for the last, I want to say 10 years, something like that. And I actually, and that's consumer drives and recent, although typically I've been buying the Western Digital Blacks in that series. And as of more recently, within maybe the last, when did I get my NAS? Year or two ago, something like that, when I actually built it out. I've got basically Western Digital Red Pros in there, and I have not had a Western Digital drive fail on me yet. I know they will at some point, but long story short, like, I've been running the Blacks for like same drive for like 10 years now, and it's been just fine. So granted, I'm not running the Blacks in the NAS right now, and I've actually pulled them out of all the other, I've kind of decommissioned them. I pulled them out of all the other computers that have been in use since I consolidated all my storage to the NAS. So I'm not sure I'll be able to figure out just how long they actually last, but at least my track record so far with Western Digital has been really good.
Awesome. Like I said, in the past, I definitely had some bad experiences, but this was like maybe 7-8 years ago, maybe more. So it were different times. As we're seeing from the charts, the manufacturing process is maturing. It's getting better. And one interesting thing to point out here, if in the past, the general experience was SATA bad, SAS good, and now we're seeing that SATA is actually pretty good when it comes to failure rates. That could also mean that SAS is probably even better. Mm-hmm. We don't have the numbers on that, but that's just a general assumption made from that generalization. And we'll just see. Like, I'm running all SAS. I'll see in a few years how well that RAID array operates. Granted, I am using Seagate, so there's still a very big risk factor there.
The other thing we kind of see from these curves too is that each of the manufacturers kind of like ebb and flows through that failure curve as well. So it could just depend on when you get your drives from a particular manufacturer too, of whether they're on the higher end of that failure rate of their kind of trend cycle there, or they're on the better side. Especially like we see some pretty wild swings there on Seagate, for example. So in like Q2 2020, they're under 1%, but you just go a couple months back of, what is that, like Q4 2019 or so, and they're above 2.5%, like 2 3/4 or something like that. So it might depend on where you are in the cycle for what you get as well.
Yeah. Let's dig a little bit deeper as to like the SKUs and the manufacturer and how long like maybe Backblaze has been running some of these. This Seagate 6 terabyte drive has been in production for 80 months. And look at its failure rate.
Yeah, that's interesting. And so they bought just shy of 1,000 of these, 886, and they only had one fail in that time. Interesting.
At least that's what I'm reading from this chart. If I'm reading the chart wrong, please drop a line in the comments and inform us how we should be reading this chart. But we definitely see some interesting figures here. Like they've been running 10 terabyte drives for 50 months and only 27 have failed. That's 2%. These numbers overall look very good for all these SKUs. But, with these numbers, you can begin to strategize as to like which one fits your risk model more. And obviously the prices for these will vary, especially now with the cryptocurrency craze of Chia. I don't know if that's still a thing, but we all know that there was a hard drive. Hard drives were in demand.
So Chia being the cryptocurrency that's based on how much storage space you have to mine it rather than how much CPU or graphics card power you have to mine it.
Yeah, exactly.
So the interesting thing that I'm kind of seeing from the chart is it makes me wonder if we're seeing any particular bias in this data from Backblaze buying these drives in bulk, in batches, essentially. Because if they happened to get a bad or good batch statistically that came off of that manufacturing line, the next batch that came off the line maybe doesn't have the same failure rate. I'm not sure. It makes me wonder if we're seeing possibly any of that in these stats. And I don't know if we know for sure, but just thought I'd point that out.
Yeah, that very well could be. But we did see that the failure rate trend in general is normalizing. That could be just a small outlier, as we saw from those two Seagate drives with bad firmware that Backblaze had in, was it Q3 of 2021?
Yeah, I guess you make another good point with the firmware too, kind of extrapolating on that. If you've got drives that have been out in existence longer, like that gives them more time to work on firmware for the whole series in general, for example. So like that's just more mature firmware the more years that product line is in production. So they could have worked out more of those bugs, more of those kinks in the firmware and stuff like that. They could have also come up with better testing procedures as they're coming off, as the drives are coming off the manufacturing line and things like that. So they could have definitely been, and probably, I'm sure they did, learn from those mistakes along the way and applied them to these future batches. And that wouldn't surprise me as we see them coming down, is essentially the technology itself is getting a lot more mature.
Yeah. Now that we have a better idea as to maybe what brands to select, what SKUs, what should we not be doing? And maybe what are some of the traps that we can fall into when we're buying because, the sticker price looks really good. There's this one item on Amazon. I know you know which one I'm talking about.
I'm actually not sure we should point out bad items specifically.
Okay.
Maybe just talk about things in generics in that sense, so that we're not like shaming any particular products.
Okay, very well. It's just,
I mean, long story short, because I'm pretty sure I know what you're talking about, and like long story short, it's rebranded,
recertified.
Yeah. So like it's some drive that's come back that has failed before, or came back in from some kind of warranty service before. Whatever manufacturer that made that drive, whoever OEM'd it, fixed it and then sold it off wholesale to some other manufacturer who does not actually make their own drives, but they're just they purchase up ones from major manufacturers. They slap their own brand's label on it, and then they go off and resell it.
Yeah, that's the gist of it. And that could be a very tempting route for beginners because those drives are typically going to be just much cheaper because they're refurb drives. So it's not going to hurt the pocket. It's going to be affordable, and it's going to allow you to maybe offset some of that cost to a better chassis, a JBOD, however you want to go about, architecting your storage appliance or storage solution. But as we kind of talked earlier in this conversation, it's really about that risk that you're willing to take here. If you are adamant about buying refurb drives, get them from a reputable source, and make sure to ask good questions like how many hours have these drives been on for if they're just flat out use drives. How many reads and writes have been made to the drives? And these are stats that anyone could pull out using the smart control tool, CLI tool, or any other GUI. And just see if you're comfortable with those numbers. There's also fully recertified drives, which refurbished drives from the manufacturer that we talked about earlier, where these are drives that are like new and are labeled as like new from that manufacturer. And those might be perfectly fine for a getting started kit because they've been assured to be like new by Seagate, for example. And they most likely have up to that 5-year lifespan. Refurbished drives might not carry the full 5-year warranty. How it works is just if you've had the drive for 3 years, you return it because it fails, you have a remaining 2 years of warranty on that new refurb. But if it's like new, then it should outlive the 2 years. It should theoretically live up to 5 years, in some cases up to 7, as we saw in some of the Backblaze stats.
Yeah, and let me play devil's advocate too around the really cheap and maybe less reliable drives here. And one thing to think about there is what's your use case and how much does that reliability actually matter to you? Number one, it may be to put that into perspective. It would be what if you're not necessarily using these to back up your company's data, like your invoices and your sales records and stuff like that? Maybe you're not using it for that. What if you're using it for something that's home use, home lab use? Great example, because you probably don't have as much money to start out there when you're just starting. Maybe you're just maybe this is your first dive into seeing if you even want to build a home lab. And just playing around with what can ZFS even do for me, to start with before I actually go out and buy some super micro server or something like that. Maybe you just want to attach some to your desktop machine that you already have and start playing around with that, maybe in a virtual machine or something. And so what if you've got that case where, so maybe another good example of where your data is not as mission critical. What if you've just ripped some of your DVDs or something, and so you don't actually have to watch them off of the physical DVD themselves, you've just ripped them onto your drives. Do you really care if those drives go down? No, you've still got your physical copy of the DVD. You can always rip it again and watch it on your media player, again. So if you have a hard drive failure, it's not that bad because your data loss doesn't actually have that big of an impact to you. The other aspect of that is we also have tools in RAID to help give us more resiliency. So if we are using less reliable drives, maybe we don't want to use RAID Z1, which gives us a threshold of 1 drive failure. Maybe we don't even want to use, so maybe we jump straight up to RAID Z2, which gives us 2 drives. It lets 2 drives fail and we're still okay. 3 drives have to fail for us to lose the pool of data. Or maybe we even go up to RAID Z3 if we're using like really unreliable, drives we really don't trust. And that gives us 3 drives worth of failure and we're still running. So, maybe you buy 8 of these drives for, a third of the price that you could get the brand new, I'm trying to think of the term, for like a Seagate or a Western Digital or something like that. But, one of those name brand manufacturers, maybe you're paying a third less for the generic brand or that relabeled refurbished drive. And maybe you can afford 8 of those drives at that point because they're significantly cheaper. So maybe you can turn 3 of them into parity drives.
Yeah. And I honestly think it's definitely a good getting starting kit, essentially. If all it is that you want to do is play around with the ecosystem, learn it, and maybe implement it with data that you don't really care about. And media is a perfectly suitable application because it's something that you can reacquire by re-ripping. I'm personally lazy, and I have a folder of like 500 Blu-ray discs, and I don't want to rip 500 movies. So in that case, safest bet, RAID Z3 and call it a day.
Mm-hmm. Cool. Is there anything else we need to know about this?
That's all I have for today.
Awesome. Well, this was a really great overview and definitely some great things to think about here when considering drives and what you might want to use to build out a RAID array or your own storage cluster here. So this was awesome. And we'll catch you all next time on the next episode of Full Stack Engineering.